One of the fundamental components of any programming language is the ability to make decisions, decide to go down one path or the other based on some test you can run. And in Python, this is the if, elif, else block. So let's look at this code sample we have here. We have some command we're trying to get from the user. Imagine this is a command line app. It can enter commands to run or execute at this point in our application. So we're going to ask the user to enter either L or X, but of course they could enter anything, right? That's just open text that they're going to type in. So we also have to account for that. We have these two commands we want to work with. And we say if the command is equal to L, the string L, the way you do equality in Python is double equals. So command equals L. Then we're going to indent and run some code. We're going to list the items. If it's not the case that it's L, then we want to do another test. We'll say, well, maybe if it wasn't L, else if, which is abbreviated in Python to elif, the command equal X. So maybe the command is X. In that case, we're going to call exit. And if it's neither of these two things we expect, well, we can just print some message like, sorry, I don't know what you meant by whatever it was you typed in, right? This is not a valid command. So these conditional statements always start with if, and then they optionally have an else if, and they optionally have an else. And of course, this is a key building block for our game to decide if the number is too high or too low. So we've seen that you can do equality tests, equals, and we can also do less than, greater than, these types of comparisons that are pretty conceptually straightforward. But in Python, you can test any object, anything that is a variable, you can put it into an if statement and it will either evaluate to true or false. And there's a simple set of rules around when a thing is going to be true and false. A lot of code in Python leverages this concept for conciseness, which I'm calling truthiness. So the rules are like this. There's a set of defined things that are false. Obviously, the word false, capital F, is itself false, but also collections, lists, sets, dictionaries, and so on that are empty. By the fact that they are empty, that considers them to be false. Strings, treat the same way. For all sorts of numbers, if the number is 0, then it is false. Otherwise, it is true. And of course, any object can point to an actual thing, or it can be pointing at nothing. In Python, we call this none. Other languages call it null or nil. In this case, when you have a variable that points at nothing, that's also false. So if you're not in this short, clear set of things that are defined to be false, then it evaluates to true. So you'll see a lot of code leveraging this concept around loops, around conditionals, and so on.